Hello and welcome to this video on topic 2, water purification. So please make sure your phone is off and not on to distract you, and you have a pen and paper to take some notes. So water is incredibly useful. It's essential for all living things to drink, for us to sort of make sure the chemical reactions in our cells are able to continue, and we need to get it from somewhere. Now, we drink often water from the tap or water from bottles, and it is safe to drink, and it is known as potable water. So it's potable water means it is water that is safe to drink. Now, it's not pure water, so it doesn't just contain H2O, but the substances in it are not harmful. So the substances in it are things such as, we've got very, very low levels of minerals and ions. So we've got such things such as minerals and ions. So things such as sodium, potassium are in the water. If you look on a water bottle, you'll see that it says it's got different things in there. They are in there, but they are not harmful to us. Now, we have to treat water to make it safe to drink. So obviously we can get water from the rain, rivers, the sea, but that water is not safe to drink. It is not potable or potable. So we need to treat it to make it safe to drink. So that's what we're going to have a look at in this video. So we've got a few things here just sort of showing what's going on and how we can make our water. So I'm going to annotate this diagram, to sort of copy it down or follow along with it. So our first bit, we have a reservoir. So this is just a large body of water that is stored, and it's where we get our water from. We then take it out and we treat it. So our first step that we've got here, we've got these large metal grids. So they're kind of large grids. And this is our step 1, which is filtration. So our filtration is to remove insoluble objects or things such as leaves, twigs, anything that's large and in the water, to remove it in there. So we remove insoluble solids. And we're talking about large insoluble solids such as leaves, twigs, anything that might just be floating in the water. We come through and we have our second stage, which is something called sedimentation. So we have stage 2, we have sedimentation. So we have sedimentation, and sedimentation allows any impurities to sink to the bottom of the container. So we allow impurities to sink to the bottom of the container. This, if you get some water that's got a bit of dirt in it or something in it, if you shake it up, it gets all a bit murky. If you leave it to sit for a bit, all of that dirt sinks to the bottom, and you get what looks like fairly clear water. It's still not completely safe to drink, but it looks a lot clearer. This part here, so these next two parts, we're going to add in, so we add chemicals such as aluminium sulfate. And that clumps the dirt together. So it clumps any leftover impurities together. We don't really need to know too much about this stage, but it is worth knowing that it is added. We've now got another sort of filtration thing. So we've got a fine filter here. So it's a fine filter of sand and gravel. And it just allows anything else just to go through. So we get what looks pretty clear at this point. But we have our stage here. So our stage 3, our third stage we need to know about is chlorination. So for chlorination, this is to kill any bacteria or microorganisms that might be present in the water. It's just like they do at a swimming pool. We've got chlorine in the water, and that's to kill bacteria or microorganisms that are in there. They might also use ozone or UV light to do the same as well, but our main one is chlorination. Our last bit here, we want to check the pH. So we're going to check the pH to make sure it is neutral. And that is a pH of 7. Well done if you remember the pH of 7 there. If it's not neutral, we can add things to it to get it back to being neutral again. But we've got 3 stages here. We've got our filtration, sedimentation, and chlorination. Those are the 3 main parts we need to know. Want to check the pH. Off it goes to factories and homes, and it is now potable, so it is safe to drink. So, our 3 main steps for producing potable water are filtration, sedimentation, and chlorination. So filtration is to remove large insoluble solids. Our sedimentation, so the reason for our sedimentation is to allow impurities to sink to the bottom of the container. And our chlorination, so it's adding chlorine, is to kill bacteria or microorganisms. That's really important at this point when we talk about chlorination. It's to kill the bacteria or microorganisms. We are not removing them. Because they are still in there. They've just been killed, destroyed. They are still present. We are not purifying the water. To be very careful with our language. The word purifying would mean that we are turning it into pure water, so it would only be water molecules. It is not. There are still lots of other things in there. Those things are just not harmful. We're going to do some questions now. So please write down the answers to these. So what are the 3 main steps for producing potable water from wastewater? Please pause the video. You should now only be watching if you have written down your answers, and well done if you got filtration, sedimentation and chlorination. We do want them in that order as well. You need to have them in that order. Okay, next question. Why is the water filtered at the start of the process? Please pause the video and write down your answer. You should now only be watching if you have written an answer. The answer is to remove large objects in the water, such as leaves and twigs. Well done if you got that correct. What is the purpose of sedimentation? Please pause the video. You should now only be watching if you've answered the question. And it is to allow the impurities in the water to settle to the bottom of their container, or sink to the bottom of the container. Why is chlorine added to the water? Please pause the video. You should now only be watching if you've written down your answer to this question. And it is to kill any bacteria or microorganisms in the water. And that keyword there, to kill. Our next question, why is potable water not the same as pure water? Please pause the video. You should now only be watching if you have written down your answer. So potable water contains other substances than just water. Pure water only contains water molecules. Well done if you got that correct. I'm going to have a quick look now at something called desalination. So desalination, D means not, and salination, you might recognise that word saline, you might have heard of in hospitals. For example, you watch Grey's Anatomy, they talk about saline. That is just salt water. So we are getting salt out of water. So we are removing salt from water. Now, some countries will use desalination to make their drinking water because they don't have a good supply of groundwater, such as reservoirs or rivers. So they use water from the sea. So that contains a lot of salt. Now, we can't filter that, so we have to remove the salt from it. And that process is called desalination. It's very, very similar to distillation that we'd have looked at in the previous video for separating techniques, but they do it on a much, much bigger scale. You'll see here, we take in 100% seawater. We only make 45% is drinking water, 55% is returned to the ocean as brine. Brine essentially is very salty water. Now, the problem with this, it costs a lot of money. And it is very inefficient. Unfortunately, people do need drinking water, so it is something that is important to do. They do add minerals to it. At this stage here, it is just pure water, so we do add minerals to it. Now, the time we might use pure water is when we do it in a lab, if we're using water for something, because it contains no other ions. So this is now distilled, and it contains no other ions. Thank you very much for watching. I hope it's been useful. Please go back over it again if you are not clear on anything. Take care and have a good day. Bye-bye.